So we're going to start off the Pythagorean theorem with an animation. Everybody knows that a squared plus b squared is c squared, but you maybe don't know why it is what it is. The animation is, there's no sound, so I'll kind of narrate it. So what's happening is you're seeing a square with different length sizes. It's basically scaling a, b, and c. 3 copies of this triangle are going to be copied and rotated around the square. Notice how that longest leg, C, is in the inside. And now you've got those lengths of C, and it's a square, and the area of a square is going to be length times width, which is C squared. We're duplicating that particular triangle, that square. Now by rearranging those 4 right triangles, 2 other squares are going to be created. One whose length sides have A, for a squared, and one whose length sides are b, for b squared. So as it turns out, those 2 white squares, a squared plus b squared, can fit into the big white square, which is c squared. Hence, a squared plus b squared is c squared. Okay, so let me get out of this and go back to the notes. Okay, so with that, Pythagorean theorem helps you find the lengths of the sides of a right triangle, and in any right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. So if A and B are the lengths of the legs of a right triangle and C is the length of the hypotenuse, then you know that A squared plus B squared equals C squared. Well, Pythagorean triples are any 3 integers that fit into the equation A squared plus B squared equals C squared. And there are two sets of Pythagorean triples that are very popular and are probably worth memorizing. The first one is a 3, 4, 5 right triangle, and the second one is a 5, 12, 13 right triangle. These are worth memorizing. Building off of these, you can find a whole bunch of other right triangles as well. If you double the sides of 3, 4, 5, 6, 8, 10 is also a right triangle. If you triple the sides of 3, 4, 5, then you've got a 9, 12, 15 right triangle. Okay, so you can do that with all of them. But bottom line is, in order to find the sides of a right triangle, you can use the Pythagorean theorem. We talked about Pythagorean triples already. So find the length of RS in the right triangle. Express your answer in simplest radical form. So if we want to find the length of RS in a right triangle and express the answer in simplest radical form, the legs always take A and B. Doesn't matter which order you do that in, but the hypotenuse is C. So what we're going to do here is we're going to say 12 squared plus B squared equals 16 squared. And then you get 144 plus B squared equals 256. Subtract 144 on both sides, and then you get B squared equals 112. And then when you figure out what the square root of 112 is, you've got to simplify that radical. I don't know if you do factor trees or not. I tend to not do factor trees, but I do know that 16 perfect square times 7 perfect or square root equals 112, which means B simplifies to 4 radical 7. This, by the way, happens to be RS. Okay, next one. A right triangle has legs that measure radical 8 and radical 12. What's the length of the hypotenuse in simplest radical form? So these guys happen to be square roots, so we're going to square the square roots to find the hypotenuse. And you need to remember that when you square a radical, it just becomes the number without any sort of symbol in it. Squaring and square rooting are inverses. So square root of 8 squared is just 8. The square root of 12 squared is just 12. And that's going to be equal to c squared. 20 is c squared. 20, I know drops into radical 4, radical 5. So 2 radical 5 equals the hypotenuse. This one, if the hypotenuse of a right triangle is 4 inches more than one leg and 2 inches more than another, what's the perimeter of the triangle? There's a couple ways to set this up, but I'm going to do it this way. I know that a leg is unknown. The hypotenuse is 4 inches more than that leg. Well, the hypotenuse happens to be 2 inches more than the other leg. So that means I've got x plus 2 being the other leg. And then the Pythagorean theorem says I've got to square my legs and square my hypotenuse. What you need to remember is when you square a binomial, you're using the distributive property, which essentially means that you're FOILing. So the first leg squared is just x squared. The second leg squared becomes x squared plus 4x plus 4. Remember, we just FOILed. And the third leg squared becomes x squared plus 8x plus 16. Feel free to combine like terms on the left, or just realize that x squared, the x squared, 1x squared on either side of the equal symbol are going to cancel each other out. So these guys are essentially going to cancel each other out. If I bring everything to the side where the green part is, where the x squared is, it becomes x squared minus 4x minus 12 equal to 0. Remember, what you're doing is you're subtracting 8x and you're subtracting 16. You're going to factor this out to be x minus 6, x plus 2. You're going to solve for x, and you're going to get x equals 6 and x equals negative 2. Well, we need to find the perimeter. I can't use this negative 2, but if I go back into my right triangle, I know that one leg is x, which means one leg is 6. The other leg is x plus 2, which means 6 plus 2 is 8. The hypotenuse is x plus 4, which means 6 plus 4 equals 10. And that is a triple, by the way. And then the perimeter just means you add up all the sides. So the final answer says the perimeter is going to be 24 inches. And that's it.